So there are monthly payment calculators available online that provide the details of the loan balances over the lifetime of the loan. These are called amortization tables. I can't say that. Anyway, amortization, whatever. But online, as everything else online, these are accurate, some of them, and some of them are not. The more accurate ones tend to come from actual banks. So if you're looking for a monthly payment calculator online, go to a bank website to get the most accurate information. This is just sort of a repeat of what we already did. We're going to determine the total interest on a 5-year $10,000 loan at 6% APR. Now, we could use the table for this. Yeah, that's fine. We could use the table for this, but just to practice more, I'm going to use the chart. Okay, so I got 6% interest, 5 years, $10,000. Okay, 12 times 5 is 60. .06 divided by 12 is 0.005. So this becomes 10,000 times 0.005 times 1.005 to the 60. Over 1.005 to the 60 minus 1. When I raise 1.005 to the 60th, I get 1.348850153. And when I multiply all of that stuff, I get this. And then I subtract 1 from the bottom. And then I divide, and I get 193.33 for my monthly payment. But I'm not looking for my monthly payment. I'm determining the total interest owed. I have 60 payments. Which means in total I'm going to be paying $11,599.80. And from that, I'm going to take away my original $10,000 loan. And so my total interest is $1,599.80. That natural log is going to happen the 3 times. It's going to happen here, here, and here. Okay, what we'll have is whatever's in the parentheses, whatever number this ends up being, you take the natural log of that, and then you take the natural log of that, and you subtract this natural log and that natural log. On the bottom, you take the natural log of this and you multiply it by 12. So I'm going to go through this slowly and write out every single step, okay, so that you know how to work it. All right. So this formula tells us how long your loan should be. So if you go, like you want to borrow a car and you say, well, I can only afford to pay this much per month, this formula would tell you how long the loan would have to be. Now I can tell you from reality, a car loan will never be longer than 6 years. That is the maximum length of any car loan, and that is for a brand new car. Used cars, they'll only go out to 6 years if it's within a few years of being new. And then after like a certain length of oldness, they won't go more than 5 years or more than 4 years or more than 3 years. And that's because cars don't last all that long. And so they're not going to finance you a car that maybe only lasts like 2 years or maybe only has 2 years life left in it. They're not going to finance it for 6 years, because if the car dies on the side of the road, where's your desire to continue paying for this car you no longer have? Do you see what I mean? So the maximum length on any car loan is going to be 6 years. But this is one of those things that you can say, okay, well, I can afford this much per month. I want this car. Are they going to even finance me? You could say, okay, well, that loan would have to be like 10 years. No, they're not gonna. I mean, you could figure out what you could afford. Does that make sense? So, okay. So T is years. This is the length of the term in years. That's what we're solving for. M is the monthly payment. And I typoed and put a lowercase m in there. They're the same M. They're both the same. P is the amount of the loan. And then R, of course, is the interest rate. All right, so we'll have the natural log, and he wants to pay $300 a month, and he wants to borrow $25,000. And then we're going to subtract from that the natural log of the same fraction minus the rate, which is 5.9% over 12. I totally ran into myself there, sorry. Over 12 times the natural log of 1 plus the interest rate divided by 12. Okay, so the first thing I'm going to do is I'm going to take 300 and divide it by 25,000. And then I'm going to divide 0.059 by 12. Okay. Then I have to do this subtraction and this addition before I can natural log anything. So 0.012 minus the 0.004916 repeating gives me 0.007083 repeating. Then I have to take the natural log of 0.012, which is negative 4.4228486, minus the natural log of 0.007083 repeating, which is negative 4.9500107. And then I have 12 times the natural log, so I have to take the natural log again of 1.004916 repeating. Okay, so that's all the natural logs. Now, I have negative, and then I have a double negative, and two negatives makes a positive. So this becomes a plus. So far, okay? So I have 4.9500107 minus 4.4228486. I just flipped them around to subtract it because it was easier. And that gives me 5271621. Divide that by 12 times 0.004904619. And then finally I can divide those, and I get 8.956, so approximately 9 years. Yeah, loans will be by months, even months. So if it's like 8.5, you would say 8.5 years, but if it's like 8.89, you know, it's 9 years. Okay, now for reality. Is he going to be able to get this $25,000 car and pay $300 a month for it? No, because they're not going to take it out to 9 years. So he's either going to have to cough up more than $300 a month, or he's going to have to get a cheaper car. Yeah.